take over today. Anyway, thank you, Alastair, for joining us for a talk by RIPE NCC on BGP routing and security. I'm sure it's going to be utterly fascinating.
Don't oversell
Everybody will be highly engaged and massively going.
I'll try. I'll try my best.
Can I offer you this?
We're thanking you.
Have a clicky thing.
Yeah, thank you, everyone. As beautifully introduced then, my name's Alastair Strachan. I work at the RIPE NCC as one of the community development officers. We call this presentation Hijacks versus RPKI. I prefer to call it kind of RPKI 101. This is going to give a full overview of everything that is RPKI. So for some of you, it may be a little entry level. For others, it will be a very good learning for you. So for those who don't know, well, I'm guessing everyone knows, but the RIPE NCC is one of the 5 RARs. We cover Europe, Middle East and Central Asia. We basically have all the IP addresses with the person who operates the database with all the IPs. We also do a lot in regards to community building, things like supporting NOGs and great events like this. We have a lot of services. Lefteris mentioned RIPE RIS. We have a whole host of different things that we do. This presentation is going to be about RPKI. So for those who don't know, RPKI is a security framework that uses public key infrastructure and resource certification for BGP route. I know someone mentioned this yesterday, but the route thing is going to happen throughout this presentation. So BGP route origin validation, or ROV. So it allows IP holders, or it allows resource holders to prove ownership and create authorizations, things called ROAs. Now, ASNs can use these ROAs to validate the origin of BGP announcements. So basically, it's a way, it was created by the IETF for safer internet routing. It allows a resource holder to say, hey, I'm allowed to announce this person's allowed to announce this. So I've mentioned in the intro we have some types of hijacks. I'm going to mention 2 of the most common. We have an origin hijack using the same prefix. Now this is sometimes referred to as a local hijack. Now in this graph we can see AS1 is announcing prefix P. That's propagated through BGP, AS2, AS3 and so on and so forth. Now at the same time you can see here, as indicated by the international sign of a bad person, i.e. a fedora and sunglasses, we can see AS5 is also announcing this same prefix. So it is trying to basically steal some of that traffic from the actual valid holder. So in this instance, the reason we call this a local hijack is because only networks like AS6 that receive the malicious announcement and prefer it based on BGP path selection are affected by this hijack. So in this scenario, AS5 is trying to, as I say, divert specific traffic to it. Now, there's also a more specific prefix, or sometimes this is called a global hijack. Similar situation, we have AS1 announcing prefix P, propagated through AS2, AS3, so forth. Now in this instance, AS5 is actually announcing a more specific prefix from this prefix P. Now that's sent to AS6, and due to the specificity, you know what I'm trying to say, of the prefix, but yeah, because of this specificity, the traffic intended for that prefix all will be routed to AS5. As we know, BGP, if there is a more specific prefix, BGP will use that as the preferred route. So in this instance, all the traffic will be diverted to that malicious network. So this is where RPKI comes in. So how does it work? I've mentioned a few times, and you'll inevitably hear it quite a few times throughout the coming day. We have here in this graph, or in this slide, sorry, we have AS100 is saying, hey, I've got prefix Y. Now it's creating an authorized announcement to say AS300 is also allowed to announce this prefix. So it's got this declaration saying, yep, I'm giving the okay to this. This statement is then signed to ensure authenticity and then published through the RPKI repository. So now when it comes to AS300 starts to announce this prefix Y, AS200 can actually check in the RPKI repository and say, okay, I can see there's a signed statement from the original holder, from the authorized holder, to say that this is a valid route. This is valid. The AS100 is allowed to, 300, sorry, is allowed to announce this, this prefix. So basically with this, it allows to make better, more safe routing decisions. Now there's two elements within RPKI. We have the signing and the validation. I'm going to run through quickly the signing aspect. Now, the signing step involves using LAR certificates to produce ROAs, or root origin authorization. These ROAs specify which AS can announce prefixes in BGP and also set a maximum prefix length. Now this step is very straightforward, it's very quick, and it's generating data for others to use. Now it's important to note that you can do either or. You don't have to do signing and validation, you can do one or the other, but it is always recommended to do both to really harness the full strength of the RPKI system. Now, trust within RPKI. So RPKI actually uses the 5 RARs as trust anchors. It kind of mirrors the RAR hierarchy, but instead of IANA at the top, why can I not remember the department within ICANN? Anyway, instead of the IANA-led resource allocation, RPKI positions the RARs at the top, and these RARs here sorry, excuse me. So resource holders then produce authorized statements using the trust anchors for the RARs and sign them for RPKI authorization. Now the chain of trust, here we can see the full chain of trust on this. All the RARs have self-signed root certificates for all resources. Now it's important to note that's not just their own resources, but all resources across all RAR regions. Now, RARs use these root certificates to sign LAR certificates. These create authorized statements, these ROAs, and then sign them with the LAR's private key. Now, with these authorized statements, or these ROAs, the legitimate holder of an address block makes an authoritative statement of which AF is authorized to originate this BGP prefix. So what's a ROA? You've heard me say it a million times. It's an authorized statement that's created by a resource holder. It confirms that a specific prefix is authorized to be originated from a designated AS number. Local internet registries, or LARs, have the capability of creating ROAs for the IP resources they manage. There can be multiple ROAs for a single prefix. There can be overlap in the case of anycast and things along those lines. Now there's different types of RPKI we can look at. First up is the hosted. This is the most straightforward, the easiest in regards to kind of the end user, so to speak. Hosted delegates the digital certificate and ROA management all to the RARs. So LARs can easily request certificates and issue ROAs via a user-friendly platform. For us, the RIPE NCC, it's a simple dashboard, kind of a few clicks, and you can create these ROAs. Now this method offers complete automated certificate management and all of those things. It's a very straightforward process. We also have delegated RPKI. Now, in this instance, LARs, or local internet registries, host their own certificate authority. They're signing our ROAs and issuing resource certificates directly, thereby providing RPKI services themselves. So the LARs maintain a hierarchy of resource certificates, starting with the trust anchor, and ensure that chain of trust while hosting the CA. LARs are responsible for the validation of customer certificate requests, and also managing their CA software, this certificate authority software. Now, as I say, we have, I've mentioned 2 of the CA softwares. We've got Krill from NL Labs and RPKID from Dragon Research Labs. So you have to have that certificate authority system on your network. Now the next one, there's a new box there. I don't know whether it's that new anymore, but we have publication of the service as a service, that's sometimes called hybrid RPKI, and it basically allows entities to manage their own certificate authority, but utilizes a third party, often an RAR, for the actual publication of the ROAs. So it's currently provided by Aaron, APNIC, and the RIPE NCC. And as I say, it enables entities to control their key pairs and their ROAs, but by using the RAR, it ensures publication through a very high visibility service. So in this instance, there's a reduction in cost and also a reduction in the risk of operating your own private delegated CA, but also gives that flexibility to manage resources across all of the RAR regions and thus enhancing the overall protection provided by RPKI. Next up, we're going to look at the second part, or the second half of RPKI, which is the validation side. So we've talked about signing, how we create the ROAs. Now we're going to look at what we actually do with them. So in validation, network operators can download and validate these statements that have been created and make routing decisions based on those statements and that information. It's a little more complex. It involves configuring routers and devices to verify the data, but it is an important part because this is where you use that, as I say, that data created by others to make more informed routing decisions. So RPKI validation, as I say, it confirms authenticity using a public key and certificate. To perform RPKI validation, you do need to have local validator software installed. And the primary aim, as I say, is to verify those announcements known as BGP origin validation or root origin validation. So the validators themselves, this slide gives an overview of how it works. So the RPKI validator connects to RPKI repositories, either using rsync or RRDP protocol. It utilizes trust anchor locators, or TALs, to establish a connection to the repository and subsequently download these ROAs. Now, the validator ensures the authenticity of the ROA by validating their chain of trust and their associated certificate authorities. And once validation is successful, the validator then creates a validated cache that holds all of these valid ROAs. So the validation process you can see here. So at the top we have the root certificate. It's the most trusted certificate and sits at the top of the hierarchy. The certificate is self-signed and also contains a public key and a digital signature. Next up we have the LAR certificate. Now this is the local internet registry certificate that's signed by the root certificate. It also contains a public key and again a digital signature. And then the ROA itself, that just contains the digital signature and is a statement that verifies the authenticity of a prefix. So what do we do with these valid ROAs or these ROAs? Basically, as long as everything checks out, so the full chain of trust is there, that ROA is marked as valid. Now routers can then use these this information to say, okay, this one's valid straight through. If it comes through as invalid, if there's any break in that chain of trust, you can then configure the router to make decisions according to that. Discard or lower priority. There's a whole host of things that can be done with these invalid. You can either, as I say, scrap them or treat them as a lower priority. Now, what's new in RPKI? There's some stats coming up. One thing I will say, validators are a lot more mature than they were. So 5 years ago when there was a lot of bugs, there was a lot of things that were discovered. There's been a whole host of installation, configuration and documentation work been done. Also a whole lot of research on vulnerabilities and fixes. So RPKI validators are a lot more steady and mature. I've included a few options here just as reference. We've got Routinator for Okta RPKI, RPA client. There's a whole host of different validators that you can use. I will mention in this, you can see kind of the split. Routinator is sitting high at the top with nearly 80%. The reason Validator is here in red, that was actually the original Validator software that was created by the RIPE NCC. That is no longer supported, so if any of you are using it, please don't. Please make sure you move to a different Validator software. Here we can see kind of the growth and adoption. I always feel like this is a slide just to celebrate the RIPE NCC and the great work we do. Because I know that the graphs are annoyingly small, but you'll see at the top of all of them are the adoption, and RIPE NCC is leading the way in that. There is a lot of work coming, and there has been a lot of increase in other regions, but here we can see RIPE with 61% on V4 and 37 on V6. Now the next slide we're going to see, this is kind of significant changes since September to February this year, so September 2023 to February 2024. Most of the large jumps, for example, for Croatia, which is the bar, is there a laser here? No. The bar right at the end is Croatia. You can see this big jump is an incumbent side covered all of their address space. They basically have almost half of all V4 space in Croatia. So they sign their rowers, and bang, we see these big jumps. And again, it's the same with any large jumps that we see. It's often incumbents that are then signing over. My next slide is normally my favorite slide because it's my name and shame slide. All the ones in grey are IPv4 that is covered. So in the UK, we're sitting around 49%. Oh, what's happening outside? I saw everyone taking pictures outside then. We can see here the grey is covered, yellow is uncovered. So if there is anyone here from the UK Ministry of Defence or BT or EE, please come find me, because you have quite a big chunk. The Ministry of Defence actually has 14.4% of all the IPv4 space in the country, and is not covered with rowers. BT has actually over 11 million V4s that are still not covered with rowers. So there's still some work to do in the UK. And if y'all can help at all with any of this, that would be greatly appreciated. This is just, again, this is from September 2023 to Feb 2024. We can see a 4% increase in rower coverage in that time, mainly from Microsoft. They covered 5.1% of the address space in the last 5 months, and then also Vodafone and another Vodafone subsidiary made up for the other kind of 1.2 and 0.4%. So there has been an increase. It's forever growing, but as always, we could do more. IPv6 is sitting around 37.5% coverage. Now, my final slide is, if anyone is not yet interested, we have the RIPE meeting coming up in Prague. I know that I shouldn't have included this, but I'm going to do it anyway. So come to RIPE 89. It's like this, but a supercharged version. And with that, I will ask if there are any questions. And I always love when no one says questions. Oh, it's a phone call. Love that. Okay, thanks.